Hi everyone, welcome to the architecture meetup. Today we have one of our innovative friends, Rajesh Kolhai, who is the CEO of Logika location inside. He's going to talk about the Amazon cloud, which he's been working for like past couple of years. And I used to work the opportunity to work with him for a while, and with the experience of working with him, I know that he's a guy who can raise the high-level architectural idea down into the implementation level. He can work in the top architectural concept level. Also, he can fix the problem in the code as well. So he's a very practical guy from my experience. So it means I'm sure that it will not be like listening to a consultant. Right? A consultant is someone who teaches others to do things that he can't do. But finally, he's going to talk about something that he really can do, and he has been doing for the past couple of years. So I'm pretty sure that the session is going to be very exciting and informative. So over to you.
Thank you for that. I wanted to use the good opportunity when I was down here in Sri Lanka to talk to you guys if it was any interest to hear a little bit about the Amazon cloud, and by the number of people here today, it seems like there's at least a little bit interest. Guys in the back, tell me if you need it to be higher volume. This is going to be an introductory, like a 101 on the Amazon's cloud offering, which is then called Amazon Web Services, or AWS. So, first of all, I'd just like to hear if anybody of you guys have any prior experience with AWS. So, how many of you have actually used any of the AWS services so far? 3 or 4 hands in the air. And then on AWS, like how many of you guys know about, not that you normally or have tried it, but how many of you guys know at least 3 services of AWS? Okay, so that's 2 or 3 hands in the air, and that's then good. Then I'll hopefully made the presentation in like the level of prior knowledge in the AWS. So moving on, first of all, I'd like to just tell you a little about like the scale of AWS. I'll show you some of their customers. Hands in the air if you know at least 2 of these companies. That's almost all the audience. These are very big companies. They have huge volumes of data going on, like Dropbox running their entire service on Amazon's cloud. Instagram, it's like petabytes of data and incredible amounts of I/O, CPU, etc. going on. So these guys, they know volume and they know scale. I'll be talking about the AWS because that's the cloud offering that I know myself, because 2.5 years ago we took our company through the process of moving all of our servers from regular data center with physical boxes in the rack to moving all of our services over to Amazon's cloud. And we've been running all our stuff on their cloud offering for the last 2.5 years. And I'll then also share a little bit of our experiences about that. And typical competitors for the AWS will be Microsoft Azure. I'm quite sure that some of you guys are familiar with that offering. You also have Rackspace, Terramark, etc. But I think, and of course, Google with their Google Engine, etc. But Amazon is by far the biggest, with Microsoft on very good second place. So before I go into the services, I'll just talk very briefly about their main infrastructure. Dilipa said they started a couple of years ago. Actually, they started 7 years ago. Time's flying. Their first data center was started in the east coast of the US in 2006. And since then, they've expanded all over the world. So they have, in total now, they have 8 what they call regions. Each region has between 2 and 3 and up to 5 geographically separated data centers. So, and this is very useful if you have global audience. And I'll get back to that a bit later, but it has to do with latency. But it can also be used for very high availability of the services. Yeah, and I'll also mention one more thing for you. I don't know how that is locally in Sri Lanka, but at least in the EU, there are quite strict rules as to where you can put your data. So both Amazon and Microsoft, and probably more of the other competitors as well, they give you the possibility to say that you're keeping all of your data in one specific region, one of the 8 regions. And Amazon then says in their terms of conditions, etc., that they will not move your data out of that region. So for instance, for the EU, if you're creating a service for the EU market with a kind of data that prohibits you from having the data, for instance, in the US or in the Asian region, you could then be putting that in the EU region, and you will be sure that that data is not moved out of that country or region. So each of these regions, centers, are placed in one single country, and they don't move the data out of that single country. So for instance, for the EU region, their data centers are placed in Ireland. Okay, there are different kinds of offerings from cloud provider, and they're like a stack. So in the bottom of the stack, you have the IaaS, infrastructure as a service, and on top of that, with added functionality and plumbing, we have platform as a service. And then on top of that again, that's probably what you will be doing. You will be doing software as a service. So the end product that you make and you offer for your customers, that will be on the software as a service level. Okay, starting off with the IaaS offerings of Amazon, I've tried to link it to classic elements that we know from beforehand. We used to have regular bare bone servers that we put in our app. So first of the elements that I'll be talking about is the server itself. So we have a physical server, and what would be the AWS equivalent of a server? That would be something called EC2 instance. EC2 is a service that is called, it's an abbreviation for Elastic Compute Cloud. So these are basically the virtual server or virtual service that you can be running at Amazon's cloud. And You have a lot of configuration options for these. You can choose the kind of OS that you want to run, like Windows or Linux, or specialized variants of those. You can choose different kinds of families within the servers, where you either have a focus on the CPU or the memory part, like the amount of memory, or you may have a focus on both. And depending on what you need for your application, you choose the right kind of family of servers and the right size of server. Because, of course, depending on how much power, CPU, memory, etc. on the server, the price will differ. And I'm quite sure that everybody of you, if you know a little bit or heard about cloud services, know that the de facto standard of how you're being built in cloud services is by the hour. So I'll get back to that. That has a little bit of impact when it comes to cost planning for your company or for your application, etc. I also plan to actually show you guys setting up EC2 instance, etc. So we'll just see how much time we have after the presentation is done. So next up, disks. Okay, you need to add disks to your server, or otherwise it's not that much good to you. And you'll probably add at least 1 or 2 or 3, or maybe you'll add 5 and put them in an array. So you need to do the same kind of stuff with your EC2 instance. So the equivalent to adding disks to a regular server is something called EBS on Amazon. That's for Elastic Block Store. That's a virtual disk which behaves just as a block device. And the fact that it behaves just as a regular block device makes it possible that you can actually provision like 5 of those, and you could put them in a RAID on the OS level. And your virtual server won't see the difference. And the good thing about these things is that, let's say that you have a service that needs high availability, or let's just say it's Friday afternoon and you're ready to go out and have a good meal and party. And one of the disks in your physical server just breaks down. So what do you do? Like in a normal situation, you have to hurry around, try to get a new disk. You get downtime while the disk is down. You have to bring down the whole server because you need to probably bring it out of the rack, remove the disk, insert the other disk, etc. If you're running an EC2 instance with block stores, if you need, for the first thing, the block store will not go corrupt on you. And if you need to swap one or add one, you can do that while the whole server is hot. So you don't need to bring it down at all. And of course, there's an abundance of disks. You just provide it there and then through the console. Just say how many gigabytes do you want, and the disk will be ready for you to mount on the server in just a minute. Okay, so we probably want a firewall on top of our, or in front of our server to make sure that it's not publicly accessible by everyone. So the equivalent to that in the AWS world, that would be something they call security groups. All of this is very easy to set up. You can do it through console, and you can also do it through scripting. I'll get back to that as well. And you can set up a security group, which is then shared between a set of EC2 instances, or you can set up one security group per instance if you want to. And the security groups acts like a regular firewall in terms of when you edit it, you say like what kind of ports should we allow traffic on and from what kind of origin. So you probably need some backup as well. Server without backup, that's not a good idea. So in the classical sense, you probably have your disks on your server and you'll have some tape storage, or maybe write to another disk or something. The equivalent in the AWS world will be that you have your AWS volumes and you do what you call snapshots. Now, the cool thing about a snapshot is that you can do it while your volume is hot. So basically, at the point you say that you do snapshots, AWS will start backing it up, but you will have like a state of the whole disk at that very second that when you start the job. So you can continue using the disk at the same instance. Still, the backup will be an image frozen in time at the second where you chose to do the snapshots. And also you can do consecutive snapshots of your disk, and you will only be charged for the dead time. So if the data on the disk doesn't change that much, you can do snapshots every hour. Wouldn't matter that much. They can roll back to the one snapshot that you wanted to if you need to roll back to the previous version, the previous state of things. So what we typically have is setting up script or some job to automatically create EBS snapshots of the disks at some intervals, like nightly or hourly or whatever your need might be. Similar, we have, like if you scale it up a bit, if you have a SAM with a lot of data that you need to have a backup of, you'll probably have a tape robot, like a huge box with a lot of tapes and robots switching those tapes back and forth. And the equivalent of that would be that you would be using something called Amazon S3, which stands for Simple Storage Service. And you will put that into something called Amazon Glacier. And Glacier is extremely cheap, but the downside is that you probably have to wait for like an hour or two before your backup is available to you. So you'll probably have a mix. You'll do snapshots of your EBS volumes, and then at times you will also transfer the same kind of data to the S3 storage, and you have a policy for putting into Glacier. And AWS supports that you set up policies so that these things happen automatically. You can set up a policy for the S3, what we call buckets. Like an S3 bucket is like comparable to a file volume. So for each bucket, you can set up a retention policy on that. Either files this and this old should be deleted, or files this and this old should be moved over to Glacier for long-time storage, long-time backup. Just a little bit interesting info on the durability of these services. Amazon has said that this has, let's see, 99.999999% durability of objects. And just have to read this stuff. If you store 10,000 objects in a bucket, 10,000 objects, you can on average expect to have a loss of one of those objects every 10 million years. So that's not too bad. Okay, so let's talk about how we set up a server. How you'll go about is that initially you will select something called an AMI, Amazon Machine Image, which is like a template for your server. And Amazon offers very good variety of different images, and also third parties can offer their images in Amazon's web shop, so that you can use them as well with different kinds of services. And you can also create your own. I'll get back to that. So, for instance, starting a new server, you will select, okay, I'm on a Windows 8 kind of OS. I want so-and-so in terms of the kind of family server and how much capacity you should have. And you also choose which region should I start the survey. Should I start it in Singapore, or should I start it in Ireland, or should I start it in Brazil? You can choose, and then you also choose within that region what of the 2 or 3 or 5 data sets is on you put that instance in. And the instances, they're up in just a matter of minutes. Of course, you can use the same image to fire up as many server instances as you want. For instance, for clustering, so I'll get back to that as well. And here I try to show you how you can do like iterations on images. So you can start up with an image, then you create an instance, and then you tweak that instance. You install software, you change settings, etc., etc., and you get that box into a state which is like your desired starting state. So what you do then is, again, through either the web console or their APIs, you create a new AMI. So that's then your AMI. Then you can then use that AMI to create a new single instance or a new set of instances. So this is very powerful to save time. If you know that, okay, all my servers needs to be, like, if I add a new server, it has to be set up with this and this and that. You typically take some of the public images as a starting point, and add that stuff, and then you'll save a new image, which will be your base image from that on. Load balancing. How many of you guys have been involved in a software solution that included load balancing? Okay, a couple of guys in the audience. So the equivalent of setting up like a regular load balancer on regular physical servers is something that AWS called elastic load balancing, ELB. So what you basically do is you just provision that you want a load balancer, and then you choose which EC2 instances of yours that should be part of that load balancer, and you set up the criteria for deciding if an instance is healthy or not, and the load balancer will fix the rest. So it will ping the instance based on the criteria that you set up, and it will find it either healthy or unhealthy, and it will remove it or bring it back into the set of servers which you can divert traffic to. And as an additional service to this, when your service is starting to get really big, like probably quite a bit of the big customers that I showed initially, you can have something called auto-scaling. So you can set up criteria, like if your traffic volume reaches some limit, or the CPU level of your current instances reaches some limit, then AWS should automatically fire up a new instance and add it to your load balancer. And the other way around, when like the CPU falls under some level, or the general traffic does, then it can also remove that instance from your load balancer and shut it down. So in that way, AWS is automatically catering for your peaks in traffic, and also making sure that it's cleaning things up afterwards. So on with monitoring. How many of you guys are familiar with one or more of these? Also a couple of guys. It's it's very important to make sure that all of your services and instances are healthy. So regularly you use one of these, set it up to monitor all your services and instances in different ways, like what's the CPU, what's the bandwidth, what's the available disk, etc. So the equivalent for this would be CloudWatch, which is also another service that they provide. And CloudWatch is very flexible in what elements that you can monitor. And it's also quite flexible in what should happen if some level is reached, either going up or going down. So that could be firing up a new instance, moving an instance. I mean, so you can basically set up the same manually then as autoscaling. You could also do stuff like send an email, fire some service, anything basically you could trigger when CloudWatch finds that you hit some limit. Okay, next up I'll talk a little bit about IaaS/PaaS crossover, because it turns out that classifying these things is not too easy, not too trivial, because it's not really an infrastructure thing, but then it's not a full platform thing either. It's something in between. The first thing that I'll talk about is a relational database. Let's say you need a relational database. Okay, you have two choices. Either you can fire up a regular EC2 instance and you can install the database and you're good to go. But you could also do an alternative, which would be to use a service called Amazon RDS for relational database service. And what you get extra then, which is like the level above the base infrastructure as a service, is managed backups, patches, replication, and on replication you can choose that the stuff is replicated from one data center to another, or you could have read replicas within the same data center. And it also handles full snapshots. I guess that's also a little bit the same as the backup. So you can do a full snapshot of your database and restore from that snapshot, point in time recovery. So then you get all of those services as part of the RDS service. So you don't need to think about all that stuff. You don't need to think about setting all that stuff up, because that's fixed for you. So you save quite a bit of time, but of course pay a bit more, at least if it's let's say an open source database. So of course it would be cheaper to run an EC2 instance, install, let's say, MySQL to it, and do all that stuff yourself, than running this service. So it's a choice, like for the elements that you get back for your money. Is it worth like the time that you would otherwise spend setting all of this stuff up yourself? NoSQL database, they got stuff for that as well. Anyone here has done anything with NoSQL databases? Yeah, a couple of guys. So I just put up. Oh, I forgot to mention for the relational databases, they have support for MySQL, Oracle, and MS as well. And for instance, for a NoSQL database, which would then be MongoDB, CouchDB, or some other NoSQL database, their alternative is something called DynamoDB. And that's kind of a monster database when it comes to so the really, really big customers use a lot of DynamoDB to be able to handle the traffic and when they need to do database operations on a huge scale. So they also have something else which is called Amazon SimpleDB, which is like a lightweight version of DynamoDB. And just to then give you an example of what they think is simple or light, I'll tell you that the difference between SimpleDB and DynamoDB is that for the SimpleDB, it's not running on solid-state disks. All of the DynamoDB database is running on solid-state disk only because of I/O speed. And for the simple DB, we have a limit of 10 gigabytes per table. So that's simple for them. And also, if you have limited request capacity, and for Amazon, limited request capacity means typically something less than 25 writes per second. So they're operating probably on a little bit of a scale than most of us. So I'll just do very quickly on warehousing. I don't know if any of you guys are doing that. But if you're doing warehousing, they have also an offering there called Amazon Redshift, which is a very specialized PostgreSQL version, where they turn things a bit on their head, and the whole solution is working on a column level rather than a row level. And that's because of the kind of queries that we typically do on warehousing. So it's really, really fast on warehousing operations. And it's built for petascale amounts of data. So if any of you ever find that you need to use this stuff, then get in touch with me. I would like to hear about it. Okay, caching. Any of you guys have set up any caching solution? Yeah, a couple of guys. The alternative, here's a specific alternative. You could either then fire up, just to have it equally, fire up an EC2 instance running memcached, or you could run something called Amazon Elasticache. That's basically their managed version of memcached, and it will provide scaling, etc. So like base plumbing around handling the cache will be handled by them. And on big data, any one of you guys have done anything on big data? Interesting, a couple of hands. So let's say if you have to do something on Apache Hadoop MapReduce, then Amazon also has something to offer which is managed by them, something called Amazon EMR. So it's Elastic MapReduce. So it's the same thing there. It gives you scaling when you need it, and backup, etc. Search. Anyone doing Lucene or Solr? So if you do that stuff and you want to run that as a service and not having to set it up, not having to maintain it, of course on all these services, like all patches, etc., is being done by Amazon now. So instead of running Apache Solr or similar, you could be using Cloud Search. And as all the other services, these things are set up to scale way beyond what we need, but you can still start on a level that is actually on level on what volumes we are talking about. This one, I'm not sure if it could be relevant to anyone, but I'll just mentioning it. If you have multimedia and you're going to be showing that multimedia on different kinds of platforms, they also have a service called Amazon Elastic Transport. Netflix is using this for their transcoding for different kinds of platforms. You know, if you want to look at a movie on your mobile, on your tablet, or your regular computer, this can then be used to transcode the video to different devices, formatted for different devices. I'll quickly mention DNS. I don't know if any of you have done anything regarding DNS, setting it up, etc. But if you need to set up DNS, which is basically like the phone book of the internet, which translates from the name of some computer over to the IP address, so that the switches and routers are able to guide you there. An alternative to setting that up and running it yourself, you can use a service called Route 53. And this service adds a couple of nice extra features. It adds a grid of servers to bring down the latency of DNS queries. It supports weighted round robin, which means that you can set up that you push the, it's kind of like load balancing, but in a little bit of a different way. You can set up that, okay, 20% of my traffic should go to this address, and 80% of my traffic should go to this address. And then you might have like elastic load balancers on the other side of that again. But what we use it for is, for instance, A/B testing. So you bring a little bit of your audience towards a version of your application which is like the new one, the beta, and the main audience you will send to the regular. So then you can just have a trickle of users to your new version and get some feedback on how they use it, if it works, if you want to do some tweaks. And then when you're happy about that testing, then of course you can change the setup so that everyone goes to that new version. So you can actually test out the new version for a limited audience in production by using this feature. And it also has something called latency-based routing. This is more interesting for than a company with global reach, but that means that you can have your service running, for instance, in all the regions of AWS, and then you can use this functionality so that if you're asking for, let's say www.google.com, if you ask their DNS server in Asia, it will return an IP address of a server in Asia. But if you're asking the same question from a computer in Europe, it will give you back the IP of server in the European region, so that you're being directed to a server local to you, which gives you then lower latency of all the network traffic. So they also have a couple of services, maybe I'm just mentioning one, let's see, which are pure platform as a service. So, on application deployment. So we have a traditional server running an application development stack. It could be LAMP, it could be .NET with IIS, could be Apache Tomcat or Glassfish, and of course the Java, JVM, etc. PHP stack. And the alternative to this would be Elastic Beanstalk. So Elastic Beanstalk might be also a nice starting point if you want to try out the services of Amazon, because what you're bringing to the table then is your application. Nothing's written in C# or Java or PHP. Let's see what other languages are available. Ruby, Python. You can bring your application to Elastic Beanstalk, and it will have the whole stack ready for you to deploy your application. And just as in the other services, they will do all the patching and upgrades and making sure that everything is running. And they will also, part of this offering is that it will auto-scale depending on your parameters as well. So you can throw in like a C#.NET application or a Java-based application and say, okay, if I have this volume of network or this level of CPU, I want it to scale up. So you get like a set of services within this one single service like Elastic Beanstalk. And you can also, for the Elastic Beanstalk offering, you can also choose from a set of databases which your application should then be accessing. All of their own database offerings like RDS, DB, SimpleDB, but also Microsoft SQL Server, Oracle, IBM DB2, and Informix, if your application needs to run and talk to those specific databases. Just very briefly, also saying that there are some other platform as a service offerings. SQS, which is a queue service, which you can use, like if you, for instance, need a global queue across your instances, or you can also link the queue service together with the notification service, so that you put elements on the queue and the notification service will pick it up and trigger different kinds of elements to automate stuff. SES is a simple email service, high volume mail server. The good thing about it is that they've done all the stuff that is recommended when it comes to setting up a mail service to avoid your email being falsely flagged as spam. So they're using elements like to have a trace back to the origin, etc. So these are industry standards that, when followed, most of mail servers will accept your email. Just a little bit also then on content delivery. CDN, Content Delivery Network. Have you heard about any of these providers before on Content Delivery Network? Anyone who would like to know what a Content Delivery Network is? It's basically that you have your content at one place, and what the Content Delivery Network does is to distribute your content geographically. And again, it's to be able to have lower latency when the user accesses your content on a global scale. Could be even on a local scale, because it's then being, let's say, cached on the node in the network, rather than being fetched automatically or dynamically from your source. So the alternative is something called CloudFront, and you can link CloudFront to, for instance, I mentioned earlier, you have the simple storage service, S3, and within it you have the concept of buckets, which is like disk volumes. So you can link CloudFront to one of your buckets, and the content will then be distributed automatically from that bucket. You could also link it to an EC2 instance of yours if you have dynamic content. Again, showing the different regions that Amazon has. They also have 40 end nodes when it comes to their content delivery. So for instance, we're running our services towards Norwegian market primarily. So we have our service in the EU region, in Ireland. So that's fairly low latency between the countries. But then we're able to increase the speed even a bit on content by setting up that we're going to use the content delivery network, which will then mirror the content from our service in Ireland over to their node in Sweden, which is then the closest geographically node to Norway in their content delivery network. Security, I'll just mention briefly, they have a concept called IAM, Identity and Access Management. So that's basically a service that spans across all their services, where you can add authentication and authorization on a quite granular level. So for instance, and you do that by setting up security policies, documents looking a little bit like JSON in syntax. And in such a document, I could, for instance, specify, I could create an IAM user or a group, and I could link a policy to that group saying, okay, you have read access to these 2 buckets of the 5 that I have in S3. But you also have write access, but just on these directories within the S3. So you have quite a lot of possibilities when it comes to like locking down access to, or controlling access to the different services that you have. So by using this, for instance, in our company, we've been able to distribute access on different kinds of levels to the services, so that developers and even people in sales are able to do and perform some operations on the service that we use in Amazon database. Just very quickly on deployment and management. They have services for this, so that you can automate deployment, you can automate operations. Anyone of you heard about Puppet or Chef? Okay. Puppet and Chef, they're frameworks for describing how something should be deployed. Like fire up a server here, fire up 2 buckets there, install a MySQL database, install Apache HTTP server, etc. And all of that can then be packaged as scripts using these services, so that all of that could be automated. So one of the last slides I'll show you is just that they have a rich set of SDKs for most platforms and languages. And the SDKs can be used, they have support for 2 kinds of access. The one kind is for orchestrating things. That could be, for instance, create a new S3 bucket. So you could script that through your program. You could have it in Java, you could do it in Windows PowerShell, just to run that script, and you will end up with a new S3 bucket. So that's like orchestrating the service. But then you can also use the same API to, for instance, write a file or read a file in that bucket. So some of those APIs you typically use in orchestrating your services, and some of those APIs you'll use in your applications. For instance, let's say that you use your application, your application is using S3 as prime storage instead of the local virtual disks on your EC2 instance. Then you could use these APIs to read and write files in the S3 bucket. And typically, as an example on how we've used this in our company is we didn't want to give a set of users access to the AWS console directly. So what we did, but we needed them to be able to fire up and shut down a specific server. So we basically just wrote a little Java application, which we deployed on Tomcat, and we set it up with some IP restrictions. And basically, this web app shows 2 buttons for the end user: boot up and shut down. And on the server side, we're then using the Java APIs in the SDK from AWS to then trigger an API call towards their APIs to then start up that instance or show them. And then we can give access to that web page to those who then need to be able to do that with the server. Okay, I'll talk a little bit about cost, scalability, and high availability. One of the main things that we saw on cost was this is saving you the CapEx costs. capital expenses, like upfront cost. If you have a regular server, let's say that you see that you need 3 servers. So you have to buy these 3 servers. That's quite a huge cost upfront before you can start anything with the service. And we had another example is that we had a server running a RAID, and we bought, and the SCSI disks for this RAID, they were really expensive. So we're running this RAID, and one of the disks failed. Okay, so we threw that one out, and we had to buy a new one. Very costly, but okay. Put it in. I think it was like 2 weeks later, second disk in the RAID just went. And you don't want that kind of cost. Okay, that's new high cost for one disk just because it decided to go sour, and you can't really plan for that. Probably. Suddenly you just have to shell out that amount of money to keep your services running. Whilst when you use a cloud-based service, you know that you'll be paying like a small, it's kind of like leasing. You pay a small amount for that disk instead of one big amount and you're done with it. You pay a small amount, and also on the other hand, you know that that disk will not fail you because of Amazon's underlying redundancy. Of course, I mean, if you buy some equipment and you run stuff on like a cloud offering, if you keep your equipment, you will get to a point where the total cost of having it running on the cloud will surpass the static line of your initial cost of the hardware. We found that in general, when we were comparing these numbers, we had to keep the equipment somewhere between 4 and 6 years before those lines were crossed. So that means that if you're going to have a lower cost on ordinary equipment, you need to be running on that equipment for at least between 4 and 6 years, and that's when you start saving money on having regular equipment. And most probably you'll be swap that server within 6 years. So it's not that often that you end up spending less money by using conventional hardware than using a cloud offering. And another case which is quite important is like conceptual tests, test servers, proof of concept, staging. When you have the classic kind of operation environment with physical servers, so what do you do if you need a test server? Okay, you buy one more server. Do you test all the time? You don't do that. So what you have is the same cost as for a production server, most probably, because you want it to be comparable when you do the tests. But it will be idle for a long time. That's a very expensive box that you got there. And in those scenarios, cloud offerings like Azure and AWS, etc., fit that situation very well because, okay, you're testing maybe, let's say they test 4 hours per week. Okay, you fire up the server, it could be quick just as well as your production server, but you just pay for those 4 hours during that week. So it's a whole different cost. And another case also when it comes to then like test servers and proof of concept servers, you also have the ability to, of course, fire that server up from the image of your production server. So keeping your test server or stage server or proof of concept server in sync with your production server is a much smaller task than if you had conventional hardware. on how you can save on servers that don't need to run all the time. We have continuous integration for our products. Build servers running builds for every commit and every and do tests as well for those builds. And earlier on when we had conventional hardware, we have a build server, which is kind of same like a test server. I mean, it doesn't build all the time. You don't commit 24/7 on the code. So we swapped over to. I mean, you could have set this up yourself in Amazon. We then used something called Elastic Bamboo. Some of you probably know Bamboo as a build server from Fashion Software. They offer a cloud service where they orchestrate actually Amazon EC2 instances to run your builds. So you use their service as the platform for setting up the builds, configure them. Then you also configure like how many jobs should be in the build queue before you fire yet another build server. How long should the build server be idle after a build before you shut it down again, etc. So instead of maybe then having one build server and then suddenly your team has a lot of commits, and the queue is just building up, doing several builds just after each other. That'll probably take some time then. So if you're the last one to enter the queue, and if that last commit is really important to you, you could configure Elastic Bamboo to say, okay, I want at the most 2 jobs to be in the build queue, and if there are more, we'll fire up more EC2 instances, and we'll move and build the queue on them. So you could have like 4 or 5 instances running, 5 servers running builds in parallel. But the thing is, it still doesn't get costly because once it's done, it just shuts them down. So in general, when we see the bill for building in such a way, it's still small money compared to if you have to have your own dedicated build server. And on scalability, I'll give you an example also from my company. We released an iPhone application, and that application communicated with the server side. Downloading, it was a map application, and it was downloading map data to be able to have it offline. And that application became a huge success, much more of a success than we had anticipated. So the number of users who were downloading at a specific point in time was a lot higher than what we had anticipated as well. So what happened was that we saw that the performance of this one server handling this was just going straight into the ground. So this, of course, stressed us out. We just launched. Things were looking really good. Everybody was downloading and using this application, and our server side was down. This is a crisis. So how do you feel about that if you had conventional hardware? Well, I for one, I wouldn't feel too good about that. I'd have a really huge problem. I mean, you can fix that for quite some hours, bringing in new servers and setting up a load balancer. That'll be a late night. When we experienced this, the specific service that I'm talking about, it was stateless, so we could duplicate it. So we basically built an image of the server, and then we created a new EC2 instance based on that image, and we threw in a load balancer, and we added both of those servers to the load balancer, and then we were watching the traffic pattern. So it improved a bit, but it still was way too slow. Okay, so we just clicked the button and added a third one. Now things were really looking a bit better. It was going quite okay, but still a bit of a problem. So we clicked again, and it was a fourth one. We just added them automatically to the load balancer. So at 4 servers, everything was running full speed. And from that problem was identified that like things are not moving. This server isn't compliant until we had a load balancer and 4 EC2 instances being clones of, or 3 clones of the original one, plus the original one. I think we spent like 40 minutes. So that was 40 minutes of downtime to be able to set up a load balancer and 4 servers. So it turned out afterwards that we had a bit of a bug in the server-side code. It was a buffer, which was too small when doing reads. So it wasn't able to shuffle data quick enough. So once we increased that buffer, the whole problem went away. And we could discard the 3 of the 4 servers. So we weren't stuck with, like, if it had been conventional, we'd been stuck with 3 servers that we didn't need anymore. But now we could just say shut down and terminate and keep the one original server. And on high availability, I'll just mention that you can have automatically build server images. Let's say each night you build an image of your server, full image. So it's like not a regular data backup, but it's a full thing. And you can ship that image to different regions. So if things get really bad in one region, if they have a full outage, if you do this, if you have nightly builds of such images and you ship them to one of the other regions, you can actually fire up your server again from the last working version. Let's say if the whole of the Ireland region went down, we could fire it up again in the US. So at least with not as good latency, but still the service will be there. So for us, we've been running this for 2.5 years, and in those 2.5 years we had one big outage which took down one of the 3 service centers in Ireland, and this was quite early when we converted to AWS. So this is before we learned our lesson. So of course, all of our servers were in that specific zone within the region, and we didn't have image backups, etc. So our service was down for like 1.5 days. So after that, we did our lesson, and we also saw that like different customers saying that okay, for them it wasn't that much of a problem because they already had this in place, creating the server images every night and shipping them off. So if we'd done that, we'd be up and running again in like probably 10-15 minutes after that service center went down in Ireland. So being up and running in 15 minutes if a whole server center is going down, that's not too bad. I worked at insurance company before Medica Insight, and we built high availability solutions on conventional hardware. So we basically replicated our racks that we had in one location to another location, and that was like $50,000 up front, and quite a bit of money each year to just maintain it as well. Through a cloud service, you can have the same kind of functionality, the high availability, for just like, I don't know, $100 a year or something, depending on your data, the amount of data, etc. But these servers that you then clone, you don't have to have them running. They could be cold standby because it will just be some minutes before they're up and running when you need them. So then you don't have to pay the hourly usage of those images. So it's really cheap to have high availability in a cloud service. But if you're thinking about doing a cloud service, you should be thinking about this stuff from day one, because it's kind of like backup. When you need it and you haven't thought about it already, it's a little bit too late. And also on high availability, if you need to really minimize downtime, you could have an elastic load balancer. Basically, if you're starting minimal, you could have it pointing at one instance. And you're thinking about upgrading that instance. So, okay, you clone it. And then you upgrade your application on the clone. And you test it, and you see, okay, yeah, this is working. So then you just flip the pointer at the load balancer, and you can discard the previous server. No downtime. So I had a little bit of discussion with some of the developers at 99XT today, and we identified one problem where we don't have a solution when we use that, and that is if you also do an upgrade of your database, that you change the schema in a way that is not backwards compatible, then you're not able to do such thing. But if the changes are in a way that they will work both on the previous version and the next version, you can use a load balancer to clone your server to have zero downtime. So you do the clone, upgrade it, test it, just flip the pointer, and you discard the old server. Okay, I'll talk a little bit about cost caveats, pitfalls. Like when you start using this is really fun. It's so quick to fire up a new instance. Yeah, that's one. Let's have one for the proof of concept. Yeah, that's cool. We're running that one. Oh, John over there, he needs one as well. Yeah. So it's so easy to fire them up, and if you don't have like if you're not janitoring these instances, you'll be surprised how quickly you end up with quite a bit more EC2 instances that you thought that you actually needed, and you probably don't need that many. But of course, you're then paying hourly usage of all of those. So you should have a regime where you have a policy and a way to make sure that unused instances are being shut down. Firing up the wrong type of EC2 instance. What we did at the Data Insight was we actually tested the different instances and how they were performing. This is also really cheap in terms of both money and time. So we fired up an instance and we set it up we fired up a default instance from Amazon. We set it up with our application, all the stuff that it needed. Then we created an image for that. So then we can use that image to create a new server, only now this time we choose one from a different family. So we can choose one with more memory, or we can choose one with more CPU. But the main server itself will be the same. And it just takes a couple of minutes to then fire up the different kinds of server types and test them. So then we can stress test them with our application and see, this one didn't cut it. And, it went too slow in replying when we hit this threshold. But this level is okay. So then we know, okay, this level is okay. We don't need that high level version of the server, which will be overkill. Because of course, there is a link between, as I said, the level of what the different kinds of server levels give you and the corresponding cost per hour. And yeah, this one is basically linked to the first one, that you don't have a real policy on managing your servers and make sure that you shut them down when you don't need them anymore. Also, one thing that we've seen is that servers are really not that expensive in but when you start piling up quite a bit of data, then that can be, like when you sum all that data together, it can become more costly than you might thought initially. But then of course, we're talking about maybe 2 or 3 terabytes of data. We're shuffling quite a lot of data in our company for maps, a lot of vector data for maps to be able to render just like Google Maps, etc. And those data then make up a terabyte or 2. So we're a bit surprised ourselves on like what's the monthly cost of data storage compared to what you pay for the service. So that's just a little heads up that you should also do some calculations on like what you think will be your level of like how much storage do you think you'll be needing and what will that cost you. And also, again, just as the servers, you know, you fire up a server here, you fire up a server there. When the disk has no limit, it's also very easy to just store a lot of stuff there and never do any cleaning. So that's also something that we saw. We had gigabytes upon gigabytes of duplicated data because nobody bothered to have a look at that because it didn't matter. If you needed to push another 50 gigabytes, you do it. I mean, that like S3 will never hit any limit. It will just increase as you put data into it. There is no upper limit. And the last one, if you decide to go for using AWS, you should also you should really do your homework in calculating different kinds of scenarios and what the cost outcome will be. Because what's very costly is if you start running some servers and you end up running them for like half a year or 1 year. If you then don't add to that something that Amazon called reserved instances, it will become much more costly than needed. So if you know that you will be running a server 24/7, you can buy like this is kind of like a hybrid then on a regular server and having the full cost up front. Because what you do is you pay up front that you say that okay, yes, I will be using an EC2 instance for close to a year or 3 years, and then per hour the cost of using that server will be much less. So you save a lot of money if you know that you will be running a server for a given period of time, and then has it as a reserved instance. Okay, it's 7:30. We had time to show, like, to fire up EC2 instance. Any interest about it to see it? Okay.
Maybe any network as well. Oh, that's good. So it's a bit of a low resolution on this one, so it might be a bit hard to see because the AWS console needs a bit of screen resolution. So we'll just see how this goes. So logging into the web console that Amazon provides. I'm logging in with my username and password, but on the, I don't know if anybody of you remember that I talked about IAM, the authorization framework. It also supports something called MFA, multi-factor authorization. And at least to us, to only have
a username and password between us and all our servers, that is way too high risk. So we're using multi-factor authorization, which basically means that it's something that you know and it's something that you have. So you know your password and you have your some kind of device that will give you a token you can also add to the system. And AWS supports token generation from an application from Google actually, which is called Google Authenticator. So that is available for iOS, Android, probably more as well. This one actually works. I mean, Google has support for this as well. So if anybody of you guys are as paranoid as me when it comes to access, then for your own Google account, like the Gmail, etc., you can set it up so you need this in addition to your password. So then you're quite safe that your account won't be hijacked. Same also goes for those of you who use Dropbox. Dropbox also supports multi-factor authorization. So I'm firing up the application and I'm getting the tokens, and the tokens are time-based. So there's like a clock here that ticks, and the token is valid for 60 seconds. And then I have to add it into the computer, and on the server side, they will, by some magical means, be able to find out that this is you. So I've kept this page open for a bit now, so it could be that it fails because of that, because I've seen that before. If I keep this page stale for a while, then try to enter the key activity again. So we'll just see. And we're in. Okay, so for this specific account, we have more than one account because we have different business units, and we have one account per business unit. So this unit is running currently running 8 servers in, and we're not able to see that, and I'm not sure how to change it either because it's outside the screen. On the right-hand side, normally you'll be able to change which region you're using. But I would like to show you that I would switch to the Asian Pacific region of Singapore, to show that we also have some running instances there. And the reason for that is that their test servers, which are being used by developers here at 99 Technology, and to avoid that those developers have too high latency when they're working on this, then we won't fire them up in the EU region, which is the one that we're currently seeing. So that's why we fired them up in Singapore to have the lowest possible latency when the developers are using those servers. So I could, for instance, check, okay, what are those 8 prime servers? So again, it's not that easy to get the full overview here because of the resolution, but you're able to overview of the names, instance ID. There are like these little cryptic tokens everywhere. Like you have an instance, or you have an EBS volume, or you have some element that you created in AWS. That element is identified by such an ID. So for all the APIs, then you use that token to uniquely identify like V1 server or V1 disk volume or V1 machine image that you want to work with through the API. And we can see what state they're in, if they're running or not. Are they okay in terms of, I mentioned CloudWatch. So we have CloudWatch monitoring these servers. We have Linux servers, we have Windows servers that we run. And of course, I mean, I could be showing you like how this CloudWatch look, etc. I think maybe we should just for now show that we're firing up a new server instance and see how long that takes before you're able to start using it. So, we choose to launch an instance. So we have a wizard quick launch or classic. Maybe we should do the quick launch, see if it's a little easier. So they have a good focus on security at AWS. So what you do when you fire up an instance is that you link it to a key pair. It will either be an existing key pair or a new key pair. You have to use that key pair to initially access your server. So I'll use one of the existing keys. Crashes, then I might have a problem. So I won't be able to pick the next one. Anyone from 9X know if we're able to do something about resolution on this thing, or? Yeah. Yeah. As I never have to use the button, what was it? Hey. That seems to work. Now we're even seeing that we're in Ireland. So then I could also show, thanks for the tip. I could also show you then like we're running instances in different regions. Then we'll be able to move on. So these are like server images that Amazon provides. But you can also, like by using the classical wizard, you can choose your own images that you already have, the Amazon machine images that you may have created, and you can also search for third-party images. So let's just choose Windows somewhere here. I'm more of a Linux man, but I think maybe Windows is more recognizable before I to log into the box afterwards. So we'll use just a basic 2008 server. Or what the heck? Let's do 2012. I'm able to select it. Okay. It wasn't too obvious that I was able to select it, but it seems like it went okay. So this is the default configuration that it proposes to me. At the very smallest kind of instance, how it should behave when you shut down the image, the instance of the server, because that could be that it just stops and you can start it again. It could also be that it actually terminates, so that the server is just vanished if you stop it. If I wanted to change any of this stuff, I'd just go I wanted a bigger server. I want a large server. And availability zone doesn't matter much. I can put it anywhere. Where it could matter is if you have servers there already, because traffic within a zone between your instances, that is for free. But if you have instances in different zones, then you pay for traffic between the instances when they communicate over TCP/IP.
And yeah, just we can also say that we want to remove these two. We have not really see the size of the volume, but let's see. We want to add a second disk, should be 120 gigabytes. Add that. Stores as well. Just remove those. So an ephemeral disk is a disk that disappears when the instance is being terminated. While you can also have disk instances that survive that you kill, like the server that they're connected to. So you can choose if the disk should go away once you terminate the instance, or if it should be staying, have a lifespan which is longer than the instance itself. So the ephemeral instances is the ones that will be removed once the instance is terminated. I'll just remove them now and not create them, just in
case they clutter things up a bit on showing that the disk is actually added.
So we're saving it, and we're launching it. Okay, so
It's on its way up.
and this is the unique ID.
If I want to access it in some way, like through the API, to be able to fire it up, take it down, terminate it, whatever.
So here we go. This is the instance. So as you can see for the state,
It says pending, so it's on its way up. So once it changes from pending to running, it's ready.
and it's ready.
So now we have a new server, which we can log into.
So I'll click on it to get the details. Not able to. It's a little bit hard to actually click the right thing on the screen. So you get a lot of information here.
About the state and what disks are attached, what's the private IP, what's the public IP, and that's probably the most interesting one.
To be able to log in. And here's the public IP. So we have one for the remote desktop. For now, I'll just leave the username and password blank because I have to obtain that as well. And if I'm not able to reach it now,
That's most probably because it belongs to a security group, which is not opening for the IP that I'm coming from. So I'll probably have to do something about that. So I'll do like this.
if it wants to give me my IP,
We'll see. This is how I'm able to get to the
AWS console, I should be able to get to this as well. Okay, so this is my perceived IP address. Maybe going through some router or something. So I'll go to the, I don't know if you recall me talking about security groups for firewall. So we'll scroll up a little bit and we'll see here, security group, Win back office. Okay. So I go to the Win back office security group. For inbound, I'll add RDP and I'll add my address. Add it, and then it's pending. So you can add more than one rule at a time and say, okay, I'm ready, let's put it into production. I'm applying the rule change. And let's see if we retry. Also fingers, should work at least. I'll try one more thing before I give up on that stuff. We'll try firing up the which is also hard to get to. So if I'm not able to connect to VPN now, I unfortunately won't be able to show you this stuff. But we'll give it one final go. Okay, so it's probably the demo effect. I'm not able to get through to the server, but what I was basically going to show you was then of course the login screen of the server. For some reason the packets are not going through. I don't think I'll spend much of your time now to try to figure that out. But that was my presentation of the practical method. And thank you for coming here and listening in on this subject. So, before you go, of course, if you have any questions. Sorry. Yes? You're asking about the load balancer?
I mean, can you configure complexities like the dependencies based on the mask or so? Just depending on the number of tasks.
Well, you can basically orchestrate anything, and so you can. The question is about the elastic load balancer and how you can use it, and if it can be on the task basis or.
I mean, how granular control do you have on the configuration of the load balancing?
Okay, so the question is how granular is your control on the load balancer, and the answer to that is that you can set up like automatic scaling, which is which Amazon provides, and that will then check on thresholds from CloudWatch, and based on those thresholds, it will either scale up or scale down the number of servers within one load balancing instance. But Amazon provides APIs for all their services. So you're able to orchestrate this in the way that you would want yourself. You can use these as building blocks. So you could have your application checking some maybe not parameters, but some elements. And given some condition of these elements, then you need to scale up or scale down. So these elements could be anything because it's your application. You programmatically set up what you want to check and how you want to check it. And then, if the conditions are met for scaling up or scaling down, you could then in your application use the load balancer API to programmatically add servers or remove servers on the load balancer. Or you can even, through the API, create new load balancers with a new set of servers. I'm not sure if that answers the question or goes a bit on the side.
I think configuration interface find API.
Yeah. So if it's like a more of a fixed interface, or if it's more of a fine-grained possibility. And I personally, I would say that this is quite, the APIs are quite fine-grained. You have that many building blocks that you're very flexible in how you want to use the AWS services through API calls from your code or from your scripts.
But any kind of subsequent integration with the data, the application developer might come and the application.
Yeah, it depends on the situation.
The API might not be providing any kind of if there's the map part, not the reduce part. You can distribute the work to different instances, but what about the integration part? If it is needed.
Like the integration across the instances, or I think when you do load balancing, you have to design your application for load balancing. So you probably have, you need those instances or the services that you provide to be stateless, or so they're not coupled to, like, that one server in the cluster shouldn't, the load balancing cluster shouldn't really know about that there could be any other servers there. So that's a little bit like how you then design your application to be able to scale it.
So I just want to question about the service guarantee. Does it depend on how big the customer are you?
Yeah, so the question is, the SLA, is it linked to the size of the customer? I think the answer to that would be, I think so, because they don't really offer that much of a, that's one of the downsides, that they don't really offer that much of an SLA. Probably if you're a Dropbox, then you can have a discussion with them, but for probably 90% of the customers, you're adhering to their default SLA, which is it's really not too impressive, the SLA itself. So they don't promise too much in it. But then on the other hand, when you read about like the fault tolerance level, like the numbers of that, and how the infrastructure that they have is being set up, at least for us, the SLA, like not promising itself 99.999 uptime on all services all the time, that was not the showstopper to us. But of
course, you need to think a little about that. They're not like legally binding themselves to a lot of. They don't promise a lot in their SLA. So you should really read the SLA if you want to put this into your production environment and think a little about it yourself. But for us, that was something that we were considering, but when looking at the whole infrastructure and the numbers that they were giving for the different kinds of services in terms of their individual uptime, not that they promised it, but that they said this is what we deliver, then that was okay, at least for us.
What about licensing? Something like do you have to wait for the license?
So the question is, if you're running Windows on your EC2 instance, do you have to pay for the license? And the answer to that is yes, but. So you pay for the license, but that price is embedded in the hourly price of the instance. So you don't have to care about the Windows license itself, but the hourly price of a Windows instance will be a little bit higher than the hourly price of, let's say, a Linux instance. You can fire up a I'm sorry. Retire? Yes, that's very good that you said it. So the question is, or maybe not a question, but more of a statement. That they have a free tier of retire. I'm not sure how you say that word in English. So if you want to try this stuff out, you can do it for free. If you go for the, you do it for free if you do Linux. Or maybe, I'm not too sure, I have to check. Maybe, it could be that they also actually are offering a free tier for Windows. They are? Okay. So for like the base level of their server offerings, the T1 Micro, you can run that for 1 year for free. And that goes for virtually all their services. I think 90% of the services that they offer, they have a free tier, like the base level. So if you hit some thresholds, like if you put more than so and so many gigabytes of data into S3 or into a database instance, then you have to start paying. But if you just make sure to check what are the threshold values for the free tier entire, then you can actually try all of these services out for free for 1 year.
Question?
Yeah, I'll have it. Yeah. Yes. So this is a bit of detailed information about their pricing, but you're able to actually have a pool of IP addresses, and you can assign those IP addresses to your instances, so that you can actually transfer one IP address from one instance to the next. But what is said here is that one should then notice that that IP address is only free when it's connected to a server. So if you shut down all of your servers and you have provisioned such an address which they call elastic IP, then you have to pay more for it. It's a minimum sum, but just to tell you. It was a question in the back.
So at what level of engagement can you establish a direct billing relationship?
Did you read that?
At what level of engagement do you have to be at before you can move away from credit card payments into a direct payment model?
Okay, so the question is, like, at what level of customer do you have to be to move from credit card payment of these services to, let's say, regular invoice?
And the answer to that is, I don't know, but I think the level is very high. Yeah.
You mentioned that AWS also supports some of the PaaS services on top of infrastructure services, which is good because it's known to be, kind of people think about it as only infrastructure services. Question is basically, does it also support multi-tenancy at platform level? For example, let's say your provision relational data service. Can you direct your traffic based on the tenant?
So the question is about multi-tenancy on the platform as a service level. But could you please just elaborate a bit on the question on multi-tenancy?
Yeah. For example, let's say you partition your database based on the customer that you have.
Yep.
Right. So when you get some traffic, you should be able to redirect your traffic based on the tenant to your database, so that you are not overloading a few of the instances for all the customers.
Okay. So
Basically, at the data level, data layer.
So the question or the comment is, if you have multi-tenancy on a platform as a service level, and you want to make sure that one customer isn't breaking the whole thing down, you can say direct the traffic to different database instances based on the customer. Is that the question?
Yeah.
I have to say that to that question, the answer is I don't know. I don't know the details about how you might be able to do such support on the platform as a service level, and it's simply because that we've built up all of our services on the infrastructure as a service level. So I unfortunately don't have that kind of detailed knowledge on the platform as a service level. But that said, AWS has a very rich documentation and description of the services and what you can do, and a lot of examples, FAQs, etc. And then you also have the free tier that you can use to play around with the service. So then I recommend that for those elements that I haven't been able to answer, that you can check out on the online documentation, and also maybe try it out through the free tier. So I'm sorry I'm not able to answer that specific question. Yeah.
My question is to be question. Like my question, I would like to ask, when we are handling the load balancing, the complexities should be handled, because sometimes some users request highly available services, sometimes some users have different layers and their message are different. So like that instance, how do you assess the complex event processing task in the Amazon?
Okay, so if I understand the question correctly, is that the question is if it's possible to, or more or less, add like business logic to how the load balancer works. I don't think that the load balancer, even if you use even if you use the APIs of Amazon, you wouldn't be able to achieve that, because the API is for like setting up the load balancer and configuring it. So it's not like a dynamic thing. It's more about, you can change the configuration, but once the configuration is changed, the load balancer has a static config on how it diverts the traffic. So in that case, I'd rather probably solve that with something like, I don't know, having some kind of URL scheme, where the URL scheme would then kind of reflect
the different kind of complexity, and then you could direct those URLs then to different kinds of load balancers. So you probably have to solve it in that kind of way.
AWS provides
Excuse me, I probably did realize I don't hear very well, so that's probably why I speak very loud as well. So
we talked about its shape as a feature in the AWS. Now, say we have an instance in Ireland,
yes.
and for some reason the Ireland infrastructure goes down. And do we have any facilities, say, to that instance to come up in a certain time frame to come up in maybe Singapore or USA? Is that automatic feature is there, or we have to facilitate that feature by ourselves?
Okay, so the question is, what if some service, let's say if it's an instance or a load balancer or whatever, is running in one region, for instance the EU region, and that data center goes down? What's the possibility to then programmatically or automatically fire these things up in another region? Is that, yeah. So you'll be able to do that then through the APIs that AWS provide. So for instance, you can then use CloudWatch to monitor your service. Maybe you'll even use, and CloudWatch is cross region. So then you could be monitoring your service, if it's a load balancer or an instance or whatever, and if it goes down, then you probably have to have some, let's say, facilitator in terms of maybe another server in another region, which is performing those, or it can be notified by CloudWatch if this service goes down. And then that server could have a threshold, so it says, okay, if I don't get a new message that it's up and it's been 15 minutes, then I will, through the API, fire up a similar service in another region, and for instance change pointers like with the DNS service, the S3 service that I was talking about. So it's possible. Yes?
When we are starting a project and at the initial stage we have to decide, suppose we have to decide whether we are going for the conventional way or whether we are going for a cloud service. So in that case, before taking that decision, we have to know the technology limitations beforehand. For example, if I say that in Windows Asia, there's a limitation that we cannot use EF code first approach all the time. There are some limitations when we are trying to do EF code first migrations and so on. So are there any known technology limitations in AWS?
Okay, the question is, are there any known limitations to the AWS cloud offerings that I know about that could be a kind of limitation that says that, okay, you have to run this on conventional hardware and service? And the answer to that would have to be none that I know of. We've deployed our stuff mostly on Linux servers, and we've done all kinds of strange stuff and computation on those, and never had any problems. And we're also running quite different kinds of services on Windows servers, because like third-party services that only run on Windows, and we're communicating with them towards their API, so we're running Windows as well. And for all of those services, we haven't come across a problem either. That said, it doesn't mean that that could be a problem, but then what you could do what you should do is to do a proof of concept or investigate in the issue. So, and then back to the free tier case, you could be using that to actually fire up such a server and see if you fit any limitations on what you plan to do. And even if you go across the border of the free tier, firing up a server for proof of concept, like if you're working like a couple of days or a couple of weeks with that server, and you just make sure that you fire it up in the morning and you shut it down when you leave work, if you're a little bit small working on it, and still the price for that, the cost that you have to pay Amazon for those servers will be commensurate really, really low. So my suggestion then is that you set up the kind of environment that you think that you will be running this in, and you do a proof of concept tests.
Have you used any of the offerings from the Amazon Marketplace? And if so, is there any benefit of you using a ready-made service from the Amazon Marketplace as opposed to you actually being on your own using Amazon?
Okay, so the question is, have we been using the Amazon Marketplace to buy third-party server images? And the answer to that is no, because we wanted our setup to be as bare bone as possible, to have as few possible elements of error or security breach, etc. So we started out with Amazon's own AMI of Linux, which is quite bare bone from the beginning with, and then we continued stripping that down, and then starting our service from an image that we built from the stripped down server. So I think this is the last question for this session.
I have a question regarding the data security that when we are using this cloud service. Now, let's say we have used one of these servers and we have deleted those stuff in there, then we just release the server, then Amazon owns that. Then what will happen to the data? Although now we know that we can recover the deleted data. So is there a guarantee that Amazon doesn't make use of this data, and what sort of policies Amazon has on this data security?
Okay, so the question is, what if I put my data in AWS and I discontinue the service that I've subscribed to? What happens to that data, and what reassurance do I have that Amazon won't be accessing and using this data? And Amazon states on their service level agreement pages of terms of usage, etc., that in their multi-tenant environment, one tenant is not able to access data from another tenant, and that they've gone to great length in adding a lot of elements and security to make sure that that is impossible. So they have a very specialized version of the Zen hypervisor, where they put a lot of work into that kind of elements as well. They also state that Amazon will not access your data. So that's basically what they give of assurance. So nothing less and nothing more than that. So they have it in writing that they will not access your data. So this being an American company and thinking about American lawyers, then they'll probably stay away from it. Okay, so that was the last question for this session. I thank you all for coming.